You can view all sequence annotation interactively along with the structure at the PDBe using LiteMol. So if you want to access the pages for a specific macromolecule, if you navigate to the entry page and move down to the structure analysis section at the bottom left, there will be information for a specific macromolecule in that entry. If you click on the molecule details, this will then link out to our sequence to structure page, and this gives you three views. One of them is your sequence. You also have a 2D topology diagram which shows you the secondary structure linkages, and there's also a 3D viewer with LiteMol to show you what the 3D structure looks like. And all of these are intrinsically linked. If you do what I've done here and you hover over a helix within the sequence annotation, this will also be highlighted in the 2D and the 3D structure as well. So here's an example of how this works interactively. So as I said before, we have the sequence, the 2D, and the structure here. At the top of the page is the sequence part with a lot of annotations shown here. And if you were to hover over any of these, for instance, the uniprot entry, this will then be highlighted on the other, on the 2D and the structure, as will the PFAM domain as shown here. If you select particular residues for the chain, you can see that these are highlighted on the 2D and the 3D structure as well. And above this bar, there are also these green triangles, and these indicate where these residues are involved in binding particular ligands. Again, below this bar, you have a quality bar, and this is linked to our validation reports, with red showing particularly a large number of outliers. And again, this is all interactively linked. And you can also show this in the 2D topology diagram by navigating here to quality, and this will show it on this picture here. And this can also be set in LiteMol if you open the tools and click on apply for validation report. As I said before, they're all interactively linked, and if you click on a specific thing, for instance here we have an issue with data, the model not quite fitting the data, we click on that and it will take us to that residue in the 3D structure. If you click again on that cartoon representation, this will open out the density in this view. And you can see here that there's a lot of red density surrounding this residue, suggesting that there isn't much data to back up where this residue has been modeled. However, there is another section of green density which suggests that there are atoms missing from this point. It may be that the depositor has instead modeled this in the incorrect place.